Okay, question 3. The diagram shows the sector of a circle with centre C. Okay. The radius is 20 and the angle ACB, the angle on there is 45. Calculate the area. Take pi is 3.14. Okay, well, if you've been watching these videos before, you know I like to just get rid of everything that's not essential because it's already on the diagram, so don't be stressed out. Calculate the area. Yep, I'm going to remember to do that. Okay, and pi is 3.14. Okay, so say this is just a circle. Okay. So if it said radius is 20, what's the area? Well, we should all know that area is pi r squared. Okay, if you forget that, it's actually kind of in the formula sheet because volume of a cone on here has got pi r squared in it. So it's got a third h, but obviously pi r squared is the area of the base of the cone, and then the third h is to do with the actual cone itself. Okay, so it's me trying to make it look like a cone. Okay, that's I've just failed. I'll just get rid of that. Sorry, looks terrible. But you see what I mean? So the third h is to do with the fact it's a three-dimensional shape, and your pi r squared is in there. So if you get the area of a circle, if you're bad at remembering stuff, you are given it. And that's actually quite an interesting fact because what that's saying is if you've got a cylinder, right, with the same height as a cone, the volume. So say this cone was like say it was like a snow cone type thing, right? So say it was all ice, all right. So, but not ice. Ice is a bad example. So say it was full of water. Okay, this is like one of those little I don't know. Used to get them in water coolers back in like the early 90s and 80s. I think they're kind of gone out the way now. Say it was like a little, cone shaped drink and it was filled with water. If you put that water into this cylinder, it would fill it 1/3 of the way up. Okay, that's what that equation means. Okay, so that's quite interesting. So if you forget the area of a circle, it is there. Again, that's just a little aside. All right, you don't need to know that. And again, if you've not seen these videos, you will be. If you've seen these videos, you'll be familiar with the fact that I like to go off on tangents. Tangent. Well, that's not a very good tangent. Go off on tangents, much like that one there. Okay. So yeah, area of a circle would be pi r squared, and you would just substitute in. Okay. Now someone's saying we'll work out the area of this slice of the circle. Okay. So again, if someone said to you, "Well, tell you what, could you work out this area?" You might say, "Well, yeah, it's just the area of the circle divided by 4, because I'm looking at a quarter of it." Okay. Now, interestingly, we've got 45 degrees. Okay. 45 degrees, just this little section in here. Okay. So that would just be the area of a circle divided by 8. Okay. Now I'm just getting you to try and think about what it is the equation that you learn is. Okay. If you're looking at the area of a sector, okay, it kind of formalizes that by saying, well, the area of a sector is pi r squared. We're going to times it by theta over 360. Okay. And theta over 360, that part is really just saying how much of the circle are we looking at? Okay, what ratio of the circle? Okay, so obviously if we're looking at a full circle, it's 360 over 360, so it just becomes 1. If we're looking at a quarter of a circle, it'd be 90 over 360, and 90 over 360 just kept reducing it down, so get rid of your zeros, yeah, 9 over 360, they both divide by 9, 1 over 4, okay, i.e. a quarter. So that's the equation that should be familiar with. And again, if you're not great at remembering equations, we'll just think what you're doing. You're doing the area of a circle times by some ratio based on the angle. Okay, so let's just write that up here. So the area of the sector is going to be equal to pi r squared times theta over 360. So pi is 3.14, r is 20 squared, times 45 divided by 360. The first thing I'm going to do is just reduce 45 over 360, and I know that's an eighth, okay? Now, I know it's an eighth because 45 degrees jumps out a mile, okay? If you were trying to reduce this would go into our divisibility rules again, okay? So, again, I could look at that and say, well, I know 45 divides by 5 because it ends in a 5, and 360 is going to divide by 5 because it ends in a 0, okay? But another thing, these divide by 3, okay? Because 4 plus 5 is 9. 9 divides by 3. 3 plus 6 is 9, that divides by 3, okay? So we could try, say it was a weird number, you could say, well, I'm going to try that. I'm going to divide by 3, okay? That's going to give me 1, remainder 1, going to give me 50. Okay, and then on the bottom, 360 divided by 3 is going to give me 120. So you end up with 15 over 120. And we're saying, what goes into both of them? Well, 15 does. Maybe you didn't notice that. Maybe you said, well, just 5. So 5 into 15 is 3, and 5 into 120, 5, 0, that would be 2, remainder 2, 4. So 24. You say, what goes into both of them? Well, again, 4 plus 2 is 6. 6 divides by 3. So you know they both divide by 3, so that's your 8. Okay? But we can just see that from thinking about, what 45 degrees is. But I think it's interesting just to try and go through some of these little points now and again, just to remind us how we would do it. And yeah, just think about what if the question was slightly different. I think that's one of the best things about the videos, is just trying to think about the small nuances that you could get. Okay, so we know that's an eighth, right? 20 squared is just 20 times 20, so that's going to be 400. Okay, again, if you're not sure about that, just do your upstairs downstairs, 20 times 20. But really, with 20 times 20, sorry, you would do your upstairs downstairs like this. Yeah, don't forget your 0 in there. But again, 20 times 20, an easy way of thinking that is, well, that's 20 times 2 times 10. Yeah, so 20 times 2 is 40, and then that's times by 10, which is obviously 400. Okay, so again, should be quite straightforward, but just different ways of thinking about it. 3.14 times that. Okay, so I think the first thing I'm going to do here is decisions. We do 3.14 times by 400. Oh, computer's upset or something. Yeah, we do 3.14 times by 400. So that would become, we move the decimal point 2 places, that would become 314 times by 4. Yeah? So we can just do an upstairs downstairs for that. We'll do 314 times by 4. That's nice and easy. 4 4s are 16. 4 1s are 4, plus the 1 is 5. 4 3s are 12. So 1 2 5 6. Nice. So I know I've got 1 2 5 6 times an 8. And obviously times an 8 means divide by 8. So 1 2 5 6 divided by 8. 8 into 1, 0, carry the 1, 1, carry the 4, 8 watts are 45, 8 5s are 40, carry the 5, and then 8 8s are 64, 8 7s are 56. So 157 to me is looking like the answer. And what are the units? Centimeters squared. Now, that was quite a nice number that came out there. Okay, let's check the marking scheme, see where we're at. That's quite a nice number that came out. It might not always be just as nice as that, okay? But if you're getting a very strange number, please go back and have a look and think, have I definitely done this correctly? Okay, good chance you've made a small error if you're getting into crazy numbers, especially when it's only 3 marks. Okay, so the first mark is working out your 45 over 360. Okay, so appropriate fraction, brilliant. The next mark you're getting is for substituting the whole equation. Okay, so you're actually getting the other mark for this point here, and then right to the end. Okay, so all your mental arithmetic, actually, it is basically first year work. Pardon me, if you're not really getting any marks for that. Okay, you get a mark for knowing what your fraction was, a mark for your substitution, and then a mark for following all that through. Okay, so quite a lot of work there for 1 mark, whereas up here, quite a lot of work. Sorry, not a lot of work for 2 marks. Okay. Question 4. How am I doing for time? I think I kind of rambled on quite a lot there. I'm gonna have to stop with that one. We'll do this in the next video.